Okay, so here's a short lesson on decomposing trig expressions into sine and cosine. And let's just remember what we need in the trig identities in order to do that. It's really important that you memorize these. The ones we'll really need if we're wanting to decompose into sine and cosine is the reciprocal of cosine, which is sine, which is cosecant, the reciprocal of cosine, which is secant, tangent, and cotangent. So these four are the ones that we need. So those are the ones you need to make sure you memorize. Let's take a look at some problems. So here we have the first problem, tangent of theta over cotangent of theta. And we want to decompose that into sine and cosine. So a couple things you could do is write tangent of theta, which is sine over cosine, and cotangent of theta, which is cosine over sine. But that would then in turn create a complex fraction. So I think a more direct, way to do this would be to separate the two into a multiplication. So if we say, all right, this is going to be tangent of theta times 1 over cotangent of theta, we can look at them separately and then we can see, I think, a little more directly what's happening without creating a complex fraction. So the first thing I notice here is that I have tangent of theta and I have 1 over cotangent of theta, which is the reciprocal of tangent of theta. So I can convert that to tangent of theta and get rid of the fraction completely. And then in the next step, I can decompose both of them into sine and cosine. So tangent of theta is sine over cosine. And another tangent of theta, that should say sine of theta over cosine of theta. And then of course I could quickly just simplify that into sine squared theta over cosine squared theta. And there you have it from beginning to end. Let's try another one. So again, the same process. We'll separate the two into multiplication, separate the two trig functions into multiplication. So cosecant of theta times 1 over secant of theta. And then realizing here that this is a reciprocal identity. Secant is the reciprocal of cosine. And so now we can convert them both into sine and cosine. Cosecant is a reciprocal of 1 over, or sine. So 1 over sine can replace cosecant. And we've already converted 1 over secant to cosine. And now we can just put them back together. Cosine of theta over sine of theta. Okay, let's try one more. And if you want to pause and try it on your own, you should do that. Okay, so maybe you tried it on your own. Let's see what you came up with. So separating these two different trig expressions. We have secant of theta times 1 over tangent of theta. And I'm going to address the reciprocal. The reciprocal of tangent is cotangent of theta. Okay, and now let's continue. Secant is the reciprocal of cosine, so 1 over cosine theta. And cotangent is cosine of theta over sine of theta. And then we can, simplify. And in fact, I'd like to cross-simplify first. Now, this final step that I'm doing here, where I'm simplifying into one term, is just an extra step. At some point, you'll have to do that anyway. I'm not going to do that with these next three, though. I'm just going to decompose them into sine and cosine and walk away and be done with them. So let's take a look at D. So here we have 1 over secant squared theta minus tangent theta, and we're going to decompose them. So first I notice that 1 over secant is the reciprocal of cosine squared theta, so I'm going to go ahead and replace that right away. And now I'm going to rewrite. So we have cosine squared theta minus tangent in terms of sine and cosine is sine of theta over cosine theta. Now I could continue and actually add those and create one fraction out of them by doing common denominators, but that's not necessary for this point of the lesson. Let's take a look at the next one. We'll do one more. So here we have cotangent cubed theta plus 1 over cosecant squared theta. First thing I recognize here is a reciprocal. A cosecant's a reciprocal of sine, so I can replace that with sine squared theta. And then we'll move forward. So cotangent is cosecant, and since it's cubed, we'll cube it over sine. So it's cosine. If I said cosecant, I apologize. Cosine cubed theta over sine cubed theta. Plus, we've already converted the cosecant into sine. Again, we could continue to combine like terms, but not for today. Take a look at that last problem. Give it a try, press pause, and then come back and see how you did. Okay, so you gave it a try. Let's see what you figured out. Here I have 1 over tangent squared theta, which is the reciprocal of cotangent, so I can replace that with cotangent squared theta. Same thing here with 1 over secant squared theta. The secant's the reciprocal of cosine, so I can replace that with cosine squared theta, and then I can convert into sine and cosine. So moving forward, cotangent squared theta would be cosine squared theta over sine squared theta minus, and we've already converted there, cosine squared theta. And that's just some basics for decomposing.